groups have reorganized so many times.
Okay.
Which group or which evolution?
As it's live. Hopefully you can hide that.
It's because I was trying to do
I think.
but couldn't do that.
Yeah.
I
Okay.
don't know how it is.
Okay. Well, thank you all for coming for the first ABCD-GIS seminar this year. I think everybody in the room knows Josh, so I'm not going to introduce him, but let's hear about the Internet of Things.
Okay. So this is completely recycled slides from a project that I've worked on for the last 2 years or so. And so many of you know one of the things I do is support the Open GIS Consortium and the part that experiments with stuff to find out if there would be a good use for standards. And so one of the activities was to work with a section of the Department of Homeland Security Science and Technology Directorate that tries to support first responders all around the country and in other countries as well. There are liaisons with Canada and Australia and Europe and others with technology and practices. And so it was kind of random. We presented a whole bunch of different proposals for information interoperability and how to use geospatial intelligence for first responders. And it was actually Raj, with his genius for sort of picking the right meme, that said, well, how about IoT? And this committee said, IoT, that sounds great. What is it? So the idea is, you know, the Internet of Things, who knows, who can tell me what the Internet of Things is? If you can, you're way ahead of me. So the idea is that there are going to be lots of sources of information about the real world. And sensors on coffee pots, and cars, and so on. So a tremendous amount of information that will be very hard to make sense of unless you have a very firm connection to the things that that data is telling you about. And so this is going to be global. There's going to be no particular limits on, you know, where sensors are or what the interesting information it might tell you. So somebody had the idea, well, you know, the only thing that sounds big enough to do that is the internet. So let's call it the Internet of Things. For the most part, when people are talking about Internet of Things, they really mean Web of Things. They mean use something that's easy and ad hoc and scalable enough to get you that information. Of course, the internet and the web are lacking all sorts of things to really tell you what data means. It's intended to put you up a lot of web pages that it's up to you to interpret whether it's fake or malicious or useful or it's a big sale going on. So there's a lot of aspects of our geospatial science that let us be more confident that a particular thing is telling us what's real or true or believable or actionable. So there's also this little confusion. So sometimes by thing, people mean the coffee pot, and sometimes by thing, people mean the thermostat that's telling you something about coffee pot. But we in geospatial science actually have a good formalism for that in terms of recognizing a feature and then recognizing attributes of that feature. So what we've done without telling them too much, because it would be confusing, is to say we can bring IoT to first responders by using some of the things that we happen to know about geospatial information, about features, and about how sensors work. Because it turns out OGC has been working for 15 years to deal with how do we turn sensors into geospatial information and put it on maps that are believable. So this represented an OGC pilot. It's a type of activity that OGC gets money from some sponsor who's interested in this activity, but then they crank on their methodology, where we put up a plan, a sort of an architecture for an experiment, put out a request for participation, and offer a bunch of basically competitors a little bit of money to cooperate, to see, can we put something together that works, that interoperates, where information connects to visualization, connects to action and feedback, and figures out what the standards are needed so that these people can then go and compete with products that actually work together. And so that's what we did, and this was totally at odds with the DHS, which has contractors and all they do is compete. They don't actually cooperate. So lots of stories that I won't get into, but what I'll do is try to step through the things that we did, knowing that there are a lot of reasons why things were done this way, not always scientific or rational, and can I try to connect it back to what this means for people who doing mapping and trying to understand the physical world, and increasingly have sensor inputs to do that with. So the mission of this group was to help first responders, such as firefighters, police, EMTs, so on, to be better protected, so safer, better connected to each other, so they act in unison, particularly across organizations that might respond to an emergency together, and more aware. So the more they know about what's going on, the better job they can do, the safer it is for people, and so on. So there's two things that are going on. One is, it used to be a lot of these devices were incredibly expensive and hard to use. Now, for 20 bucks, you can get a set of 10 environmental sensors plugged into an Arduino and just throw it on the ground and have it work. So the possibility to do stuff inexpensively and so that it's plug and play, so that it's something a firefighter who's kind of busy could actually make use of, is one. And the other is that there's a generational change. So if you're a 60-year-old firefighter or commander, you have your mobile radio, and that's all you use. And if you want to find out something, you call the command center and you say, tell me what's on this screen. Tell me what's on that screen. And that's, the way that you communicate. The younger generation say, the hell with that, I'll check Google. They carry around their phones. They're using their phones. They're pulling their gloves off to plug in their phones. So they are much more connected to connected technology, and they bring their own devices. So how can we connect inexpensive sensors and the technology that first responders are already used to and make it work together? So that was the challenge. So we wanted to apply these principles. How do we make something that's just scalable and plugs in together and integrates? And how can first responders groups do that? And how can we connect this formalism that we and OGC have come up with that give us a sense of confidence in sensor readings? And the ultimate goal here was to actually come up with a government specification, sort of a conformance program, so that somebody who's producing gear for a policeman can say, this gear is conformant to the DHS standard for wearable gear. And if you buy our power supply, it will plug into somebody else's sensors and it will communicate with somebody else's radio, and so on. So that's various people who are involved. So there were government, academic, commercial, nonprofit, all sorts of different organizations involved in this. That was me, tumbling walls. Let's go. Okay. And these are some of the things that were done. So what are the different sort of types of sensor information that were useful? Well, they sort of fall into categories. So the location is actually a pretty critical thing, but not only positioning, but particularly how you track things, meaning you identify them and you decide how often you need to know where they are, how often do you need to know their spatial relationship, and what do you need to know when that changes? And this is a classic example of the lack of interoperability. So this was done in conjunction with organizations that work with emergency response in Huntsville, Alabama, a pretty technological place, Space Center and so on. And they have a system for tracking all of their emergency vehicles, but it's a closed system. So we actually had somebody scraping the locations off of a computer monitor to put it into some of the services that we use, because they're just totally incompatible. That was true of many stuff. So the other kind is air quality, both local, so fixed, moving, so airborne sensors, and virtual sensors, meaning a plume model, for example. We ran a plume model to see, we detected, in this case, chlorine gas. Where is it going in the future? Imaging is really important, but the thing that first responders often forget about, because they're very focused on knowing where they are and what they're doing, is actually locating that stuff. So this has sort of two parts of significance. One is showing what's going on now, and showing it not only to the policeman who's parked in front and say, you know, I know where I am and I know what that image is, but everybody else who's being brought in to participate. But then there is looking at what happened afterwards, being able to replay, say, you know, did we do the right thing? Did we have the right resources? And unfailingly, without geopositioning, without locating that imagery, saying this is the time and space that this image pertains to, people would lose track. You know, okay, yeah, I think, was that the southwest? Maybe it was the northwest. I don't know. It's somewhere around there. You know, well, then I can't really interpret what that means. So that's the context, the boring stuff. You know, people kept saying, well, we don't want any more damn maps. Well, but how are you going to organize anything? Okay, just don't show me the maps. Organize stuff and don't tell me. But we did many very traditional things. Develop map layers, register them in a catalog, search for them, organize them in map compositions, at least contexts. We just didn't call them those things. We had to give them new names so that people were excited about IoT technology. Two other things. So one is not only what's around there, but what people are doing in there. You know, what are their tasks? What are their status? What's available? What is set up, particularly in terms of events? And this is probably the cutting edge of this sort of information technology, even more than really cool little sensors, which is how do you connect semantically to firefighters and let them know what's actionable? So how do you let them know there's bad gas here, but also let them know when there isn't bad gas? You know, this air is safe. It isn't just that somebody didn't turn on the sensor. So there's all sorts of, how do you inform people of what they need to know and what they don't need to know? And part of this also is reflexive, that it's important to know what the health and condition of people are while they're doing this stuff. So we had a watch application, for example, that would inform somebody that their heart rate was going too high, and they have to get out of the fire situation before their health is demonstrated. So this is the sort of as-is situation, and it seems kind of absurd, but all of these things are available to first responders, and almost always that's how they're available. So they have an isolated system, you know, literally goes from a sensor to a monitor in an operations center. And then how does a first responder find out about it? They get on their damn radio, say, could you tell me what that screen in the upper left-hand corner is showing? Describe it to me. And it's remarkable. So the idea to the to be, how would we change things, is to actually be able to integrate these things in advance or even on an ad hoc basis. Does anybody have a sensor here? Oh, cool, turn it on. It will integrate into this installation, this IoT infrastructure. And now, whether you're the commander, the analyst, or the first responder, you have equal access. You can get at this information. And you can not only access it, but you can find it in terms of what is important to you. So that was the sort of dream for this. So what are some of the patterns of information that we work from? Well, one of them, the basis of the information modeling and the interfaces that can exchange it in sensor web enablement is something called observations and measurements. And so it looks at the what a sensor does in terms of an event and a process, and it involves having a sensor, having an event where the sensor works. It registers something called a stimulus. It produces a result. But the really important part, and the part that we assume and actually needs a lot of documentation metadata to be effective, is we say all of this mechanical stuff ends up telling us something about a feature, about a thing. And that leap of informed faith is really the core of how information works to make sensors useful, except that it's mostly implicit. And so the idea here was to actually make that information implicit. And when you have a result, you say, well, I think the air composition, there's this much carbon monoxide in it, because I can look back at the provenance of that information. And this is the prov vocabulary that says, we had like the stimulus, some agent initiated an activity of sensing, resulting in a result, then another activity transformed that into this feature characteristic. And we can go back and say, was this working correctly? Was that a calibrated sensor? Were there other, things that were outside of the validity range of this, or can we depend on this information? So this is all somewhere between the oatmeal and the sausage making. But if somebody's life is on the line and you want to say, how confident are you that this information is real and relevant, you need it. You just have to hide it somewhere so that it only comes out when it's needed. So one aspect of IoT is that it's a very dynamic field. And so every company you've heard of, and many you haven't, have decided that they've solved the problem. And so they're producing these local protocols, they're personal area network protocols for wireless sensors. So just follow our fill-in-the-blank, HomeKit, Threads, Fabric, XB, and so on and so forth, then it will all work out, just as long as everybody uses our protocol. And repeat that 50 or 100 times for each company that's saying that. So the bridge between all of this very rapidly evolving technology and the stuff that we already know is something we call the CenterHuff. And so that sits down there and has these drivers for Bluetooth, that works. XB, that works. USB, yeah, that works. Interesting but totally proprietary API, well, we'll fix that. On this side, these have the set of sensor web services from OGC, sensor observation service, sensor things, or the data services, but they also connect to a catalog and tell the catalog, this is what I get. And of course, we can't train people to do this, so it has to happen automatically. It registers to a CenterHuff. Eventually, it will present its certificate, and it will be secure and reliable information. Right now, that's not really been decided, but the CenterHuff then says, I've got a new sensor. I'm going to tell the catalog about that because I have this canonical URL for a catalog. And So all the first responder has to do is turn the damn sensor on and throw it down. And now everybody knows that it's there. And the catalog is doing a couple of other things. It's also organizing that information. So if you want to see, I'm interested in heart rate across all of the victims that are being treated. The catalog actually has an extra service that organizes all of that by heart rate and produces map images. You can pull up that map image, say, you know, how's this guy doing? Poke at it, and it pulls up the actual sensor readings, the current sensor readings. It does that because the catalog can say, here's the way to connect to the sensor that is CenterHuff that's connected to the sensor, and my browser connects directly to the CenterHuff and pulls that information up. So the horse's mouth here using this infrastructure. So this is very, I would say, traditional. You know, this is the SOA. This is the publish, find, bind. But we've hidden it under this easy-to-use IoT veneer, paradigm. Anyway, so this is a complex view, actually, of a second phase of this, where we have local hubs down here. So these things are on Wi-Fi, but they're, let me see. Yeah, most of them are on Wi-Fi. Some of them are on cellular wireless, and they're talking to these various sensors. But, you know, these are not necessarily high-powered, and they're not necessarily utterly reliable. So, but because these field hubs talk standard data model and standard services, they can actually be set up in a constellation. So in this case, there were field hubs. Each scene, there was a hub. And when possible, they would also synchronize their data with a cloud-based
The field
hub.
hubs are also out there Wi-Fi or cell-connected, and they're aggregating and sort of cross-checking
Right.
the masses of sensors, stuff that's coming in. Sort of
So for example,
initial
well, this hub was talking directly, but it could be the hub is the UAS, right? So the drone has a hub.
Right.
And part of this was modifying a 3DR Solo to talk sensor observation service, sensor planning service. That talks to a field hub, which is sitting in that mobile command center. And mobile command center has a satellite dish. And it's going up here. And then if 50 operations centers or, you know, national coordination centers want to get at that data, that's fine, because the capacity for that is here. You know, the important thing is that that needs to be available, but also current. And so the synchronization is really
or
important.
at least know how uncurrent it is.
Exactly. That damn metadata. So, so these are some of the things that weren't done before. So that open integration, using an architecture that could be available to whomever and whatever wanted to participate. That dynamic auto registration, that plug and play, and then another part of this was to try to get at this, you know, relevant events problem. And some of this is just setting thresholds, saying, you know, let me know if heart rate goes over 100. But, you know, who decides that heart rate goes over 100? Or, you know, when does it matter? You know, you may just be running over to the other truck. Are you actually in a situation where it's important? Are you in an air suit? And it's really important that your heart rate stay down low. So that's complex event processing. That's taking multiple sensor inputs and figuring out when an event is occurring. And so this actually made use of an event processor that would take many inputs and run algorithms. It could be running machine learning routines, for example, to identify dangerous patterns. But having this part of the system enables this part to be inserted. And then, so these are some of the things that were developed in terms of the collaboration, in terms of suggesting what we need to develop. So one of the next steps to jump ahead is to come up with a standard for these CenterHuff devices. So they're a combination of existing standards, some things that are needed, such as a driver API, and most of all, behavior. So, which is something that OGC has not really done yet, which is to say, how should one interface behave with respect to another? For example, we say this sensor hub has both observation service and sensor things API interfaces, but they should be supplying the same data. You know, if one application connects to one service and the other connects to the other and they're getting different data, that kind of defeats the purpose. So for those that are interested, there are 4 engineering reports that were written from this, and eventually, pretty soon I hope, I will narrate some of the videos that we made, and they'll be on the OGC website as well for the non-reading among you. But the reading, they're pretty well written, I think. Personal bias. And then various activities coming out of this. So this group that's trying to define technology for the next generation first responder is continuing. I met with some of them this week, and they want to do 2 things in general. So one of them is to really figure out what first responders can and are willing to use. And that was an interesting context of this augmented reality meeting over at the Media Lab this week, because there's a lot of potential in heads-up displays, for example, but most of the heads-up displays that firefighters have used, for example, they said, this gets in my way. You know, what am I missing behind the alert box that keeps coming up? And so exactly how to do that so that it's an enhancement and not a drawback remains to be done. And the other is to see what can actually be built. And built so that it's affordable, you know, even for a small town. And so that involves coming up with this specification, this design for the equipment, especially wearable equipment, to see if anybody will build it and if anybody will buy it. So it's that, you know, getting it into the industry that's the next step. So, okay. Let me go to this. So, as I said, the scenario was based in Huntsville that we worked with. Any questions before I sort of step through the pilot scenario?
Just to clarify, sorry that I come in late. So your system is really not relying on, say, the existing Wi-Fi system in the building or something, but deploying it.
That's a very good question. Yeah. So one of the goals is to be independent of any particular communications technology and be able to transmit information over whatever is available. So this used Wi-Fi and cellular modems. There is work on prioritization of cellular connectivity, LTE, for first responders, something called FirstNet. So basically, you know, when everybody on the interstate next door starts, you know, streaming Netflix, it doesn't mean that the firefighters can't communicate anymore. So that's one thing. But increasingly, there are plans. There's a plan for Boston that might happen to establish a citywide low RAW network. So it's a sort of a low bandwidth sensor network, and so then you wouldn't need a lot of this, you know, constellation of different scopes of hubs. You just turn your sensor on and connect it to this citywide network, and things would work. But the important thing is that that keeps changing rapidly. So, you know, unless the information processing is separate from the communications, it will be really brittle.
So I've got a question about, just to see if I understand what you're saying.
Mm-hmm.
my impression is that you're saying the sensor hub is the place where it's translating each individual proprietary sensor's communication and processing it. So that's the kind of the translator that you're then using to harvest the information, as opposed to proposing universal language for first responders for the sensors.
Yes. So yeah, that's operating as a mediator and a facade. So the hub gives the impression that, you know, a first responder is talking directly to a sensor, saying, you know, what do you know? But it's presenting a facade, which is a standards-based interface. So even whatever that sensor happens to be talking or how it's talking, the hub is translating that into. One of the things that about the internet or web of things is to have for every thing and each sensor that tells you about it an address. You know, whether it's a domain name or a URL or something. So, but you know, for many things, when you go to google.com, there isn't one machine that's google.com. That's a facade that, you know, apportions your requests to whatever resources are available. And so it's doing that thing. It's called a reverse proxy, technically, but the idea is that it presents a canonical view, which is separate from the physical translation. Yeah.
I have a question about the hub cat. Okay.
Yeah.
Do you have is just a how can I say, abstract object, or did you is a URL? Is a cloud-based? I mean, what is it?
It's
Can you talk-
cloud-based. It was a CompuSalt catalog, so it's a OGC catalog, you know, catalog service for the web. It's an EBRIM-based catalog, so it could, you know, store and search a whole bunch of different kinds of information. But that again would, you know, in a real situation, have that sort of mediation like google.com. So it would be, you know, what do we call it? Emergency operations catalog.boston.com or something like that. Be a canonical URL, and all of the hubs would be set to communicate with this canonical hub. And the emergency infrastructure would redirect that to whatever physical service was providing, supporting that particular operation.
So, but who was managing it?
So one of the things that CSW can do is to federate. So the idea is that, you know, you have local operations, and when it's just a local operation, it's just their local catalog, but that's synchronizing or federating with the, you know, county, state, federal level catalog. So the idea is that you may have all your stuff set for your local catalog, but that catalog is, you know, if you're querying an operation which is, you know, being conducted at a federal level, it does federated queries of other information. So that's the advantage of using all that work that was done before, is that, you know, you can hopefully have a simple interface that is scalable to different situations.
So even the local hub could be a mini CSW.
Yes.
It probably is something like that. It is that, yeah.
Yeah. So we didn't actually do that. I mean, you can query it. It's a sensor observation service. You can say, what are your capabilities?
Right.
What sensors and observations you know. So in that sense, it's a local catalog.
And all the sensors know to write to an open standard spec when they're communicating. They can be doing whatever they want internally, but in fact, those sensors do have to be speaking open spec languages to communicate with the hub.
The sensors don't, because
Well,
the
then,
hubs support
The
local
hubs are
drivers.
proprietary?
The hubs support local
Support
drivers,
local
which could be
drivers.
proprietary.
So it's like plugins. So the
Yes.
right. And the hubs are proprietary hubs. Built
Well,
with
they can
whatever
have
mix of drivers
proprietary.
and open stuff they want. The company wants to build in there.
Right. but they're required. So I mean, they can be closed boxes, but they're required on the wide area side to support these open interfaces.
Yeah.
And to have certain behaviors. So when a sensor connects to them, they actually invoke a processing. It's a registration processing service that gets a registration request and does all of the catalog operations required to have that sensor.
Right. So
Show
the
up.
openness, you know, it's more open the closer you get to the top of the stack. And and farther down you go, the more proprietary, but that's where you want to drive the innovation. So that's the
Yeah,
kind of
and this is not a novel pattern. I mean,
Right.
most of these hubs that you can buy for your home now do exactly the same thing. They, you know, we support these 5 protocols because we don't know who to bet on. Okay, so we had a scenario because we want to have something realistic about the application of the technology, and so this was a postulated disaster event in Huntsville, and involved a truck carrying chlorine gas cylinders falling off of an overpass and affecting all these things around it, and then going through different stages of an emergency response. So there's finding out about it, time, you know, finding out what's going on. It's called building awareness, and that's the first 15 minutes. Then responding to it, which is mostly, you know, protecting public safety and getting resources in position. Then doing something about it, you know, chasing down the cylinders and so on. And then finally a recovery phase, clean up things, restore traffic, but also put all the information in place to go back and look. You know, we want to review what we did, what worked and what didn't. So that's part of the recovery, is to prepare for the post-operation events. So now we'll see if these actually work. There we go. Yeah. So try not to get too disoriented. The person who put this together loves Prezi. But this is a particular intersection, which is sort of a critical place in Huntsville and affects a lot of different stuff. So, and you know, one of the things you can see is that there's a lot of power lines and other stuff around. There was a senior living center nearby. There's a park nearby, and so all the different things that are aspects of responding and mitigating. Yeah, so these are showing some of the crash locations around the site, and then the cylinders sort of tumbling off the truck and rolling different places. So that's another geospatial problem, is what are the impacts places, and you know, what is the mitigation challenge? First of all, finding out where these cylinders are and what their conditions are. In terms of the electrical grid, that actually is something that isn't very well done, that we tried to suggest some solutions to, which is the coordination between the electric power operations center and the emergency operations center, so that each would know, you know, what lines were down, where were people, when was power turned off or on, and so on, and who might be at risk. One of the things that happens in these situations when you're not sure what the limits of hazard are is they'll establish a command post. You can see up in the upper corner, but it may not necessarily be in a position where it can oversee everything. It has to be in a place that's nearby, but itself safe, so that there's as much of a problem of bringing information in and out of that command post as it is anywhere else, like an established operations center. So, okay, so notification, it's a 911 call. What's interesting is, I don't know if this will make noise. No, sorry. So
plug in the speaker if you want.
Yeah, don't worry about it. The 911 comes in, and up about 33 seconds after that. So just as in politics, in emergency response, everything but Twitter is becoming irrelevant. But this is, starting to build what's called an incident folder. So there's a couple of systems. One is there's usually some sort of GIS system that starts to build the geographic view, and then there's another system called a computer-aided dispatch. Geospatially extremely primitive. It just has lists of resources and says, send this police car. And so connecting those together is a part of the interoperability challenge here. So that a commander and a first responder and this dispatcher actually have the same view of things and same currency. So this is setting up the background information that's needed, but also setting up the tasks in the dispatch and tasking system so that they actually coordinate, so that they work the same. And so that stuff can be mapped, for example. GeoTweets. Yeah, so the dispatcher is trying to characterize it. One of the semantic issues is using the same vocabulary so that people in different domains can understand what's going on, and using the same symbology, even when you have multiple organizations that may look at resources differently. This is starting to pull in now some of the sensors. There's a police car camera, but instead of the policeman saying, I kind of see a bunch of smoke, that feed and the exact location and bearing are available to anybody with access to the catalog and to the services. So there was a body camera here. I guess it wasn't in here. That's too bad. It was a good moment because Mike Botts, who was wearing the body cam, was very realistic. He was walking towards the highway and fell into a ditch along the way. So. Okay, so building awareness. Now we're going to accumulate more information. And yeah. So this is now that we have this incident folder of these layers and other sensor information. So both sensors and people as sensors. So this might be for citizens, Twitter information or Facebook posts, but this is also information that police and so on are entering in. And also entering in what they're doing. So for example, saying, okay, here's our traffic observation points, here's our exclusion zone. Now we're designing routing to get around the emergency area and then communicating that routing to everybody else. Wonder why their truck can't get in to a particular area. Deciding where the power company needs to work, setting up their area, where they can do triage on victims and let everybody else know that that's there. Yeah, and so this is actually taking a subfolder of the incident and exchanging it between the utilities and the response infrastructure, so that each of them know exactly what the other is doing and what is expected to be done. So when the crews turn off the power and decide, indicate where those lines are that the power is off and what buildings are affected, that goes into the incident folder and comes back to the incident command. Meanwhile, so people have thrown out a bunch of sensors, and those did what we discussed. They registered with the hub registered them to the catalog. Somebody pulled this up on their tablet, and now we have both the map and other visual formats for that information. Some of it is environmental, some of it is health and physiology sensors. And this is the stuff in the catalog. In this case, so this is the preliminary safety zones from the plume modeling, chlorine gas, staging areas that we talked about. And this is all getting added to that geospatial awareness that are, you know, those are layers, but some of the layers were, you know, already in the base information, and the others are being created as the incident proceeds. And this is tracking, you know, so that location and health status of the first responders being an important part of this. I think that's about it. Yep. Nope, environment centers. Okay, one more. So this is showing being able to query the sensor through the hub directly. If you want to say, well, that's interesting, you know, let me see what the other readings are, and how has this been changing over time. A lot of this is trying to validate the information, to look at, you know, is this behaved over time or spatial variation as I would expect for the event that's happening, or are certain sensors suspect because they're not following patterns. So in this case, a person can do that, but this is also the material that a machine learning routine can use to find patterns. Wendy?
You talked about like modeling the air of movement, right?
Yeah.
Is that soon enough done before you can decide where the mobile command center is located? What's the timing of these different?
Well, that's why, you know, that command post was so far away, right? Because you have to establish the command structure before you know everything there is to know. Yeah. So that was a surprise to us. We expected, okay, so they're going to pull up a, you know, a command post next to the crash, and no, we don't do that. You know, this command post has to be safe while we're finding out about the situation. Okay. Oops. I think we already did that one. Stop. Okay. So the next stage is response, and that's really dealing with the things that you're now aware of. Yeah, so that's going. So some of that is planning and executing UAS imagery gathering. And so this is using two things, and this is modified quadcopter. One is called Sensor Planning Service, and that is an interface to let you establish the plan for surveillance. So follow this path, and at these points along the path, take imagery of this area. And the whole idea is to translate from, you know, trajectory and, you know, azimuth and inclination of views into what actually are you looking at on the ground. So this helps you get the drone to look at what's important, but this is all getting recorded too. So once that's done, you can go back and say, not, you know, what drone flights were there, and page through the imagery. You can say, what imagery or video do I have of this particular location? You know, something went funny down here. Tell me everything from every angle that was a view of that. So, including all different types of observations. So, when people get too specialized in their particular type of phenomenon, they tend to say, well, you know, this is a unique set of information, and we don't really know about that other information. What this observations and measurements formalism does is it lets all sorts of different observations be sort of on the same, and that includes machine observations and also human observations. Say, you know, okay, this is what people are telling us, and we can integrate everything as different types of observations of the same place and time. One of the things that this also does is, one of the big challenges when a situation is escalating is you send out mutual aid requests. You say, more ambulances, we need to bring more organizations in. So those organizations are starting cold. They don't know what's going on. And using this means of integration, you could then say, no problem, here is a context file with the entire situation so you can get up to speed immediately and see what we see without sitting on the radio. Well, so there's this, let me describe it to you. Okay.
So does that evaluation step occur on the part of the sensor hub, or is that happening like in some software that the command center is running after it's been synced up to it? In other words, like you want a new party to come in with new resources, and
Right.
then they open up something that says there are 3 teams with 20 personnel and 100 sensors, and
Yeah.
here they all are. Like,
So that's an incident folder, which is a specialized OGC context document. And that context document is stored on the catalog. And that link to that context document can be supplied to whomever is coming in. And that opens up dynamically to these are the map layers, which are being served through services. Here are the sensors with their observation history. But you don't have to go through and look for them. The other way this was used.
so when you
yeah.
initiate one of these events, that is already there, and
Yeah.
then the pieces flow into it.
Exactly.
And all you have to do is attach.
Yeah.
Okay.
There's also there's a division of labor because it's hard for people on the scene to do this sort of information organization.
Yeah.
What this allows is for there to be an analyst, for example, somebody who's very familiar with manipulating this information to put together a package for a particular role. So you're an EMT. What do you need to know about where it's safe to go and where the victims and resources are? So instead of they're sitting on their phone trying to query the catalog, they can, give me the EMT folder, and somebody else can put that together, and all they do is open that on their phone, and that brings up all of the layers and sources of information that are relevant for them. It may set the event thresholds, for example, that are relevant for an EMT. So, so this is running the Plume model, I think. Yeah. So that requires, input information, scenarios that are relevant to the response, and time frames for being actionable. So showing actually the data they had was very realistic. It was a very strong wind, so it would have just blown any chlorine gas right out of the way. This is more of this UAV control. This is the response here is finding out if there are any people in affected areas that have not yet been evacuated. So it's one of the roles for the UAV is to find people who, well, I don't have to evacuate. I'm just going to sit behind this bush and I'll be safe. It happens. Another part of this is actually clearing nearby buildings for people who just sort of hunkered down, and so nobody knows if they're okay or not. And so search and rescue will go building to building, but there'll be different groups, and they'll need to know, which buildings have you cleared, which are still not been cleared. And then this is going through and making sure that the cylinders are cleared. So the sort of we're morphing into the cleanup, the resolution here of saying, okay, the cylinders are not leaking anymore. We've cleared hazards from this area. We're going to gradually modify traffic by looking at sensor readings and changing the status of these different areas, and having somebody either in the operations center or on the field be able to change that sort of designation. Here's setting up events in terms of victims' heart rates to decide, who needs most immediate attention, and then presenting. So that has two aspects. One of it is to show those red markers when there's a problem, but the other is to show green markers when there isn't, and you can look at that image very quickly and say, all green, great, the sensors are working, they're giving correct readings, and the readings are actionable in that they provide you positive information not to act. Another part of the modeling was using citizen informations like Waze, where are there traffic problems or people experiencing distress, and then having that as part of the input into a traffic modeling. Traffic model to decide, where are there points. So this is supposed to be emergency operations center. So the last thing, just very quickly, is the recovery. And the important thing here is we use the same tools, monitoring social media, using sweeps, using imagery to recover, to make sure that haven't missed anybody, to make sure that areas are clear for people to move back into, that the traffic can be normalized. But some of this is also to take all of this information that's been collected and to make it available for debrief, and so learn things about what could have happened. So I'm going to skip this because it's getting late and there's all sorts of information. So this is back to what you saw before, which was, what were things that we really did that was different. So a lot of what we did was to take things that are not so different and give them a new name. It's important, but some of it were wrinkles on the sort of standard geospatial web architecture, like the event processing and the auto registration that hadn't really been done before, because mostly they were possible, but people didn't really think of them as being important, that to have services auto register. Well, there's somebody that's doing registration and curation, but not always. Yeah, so that's it. So so that happened all up until it was this past summer, and so there are different activities following on from here. One of them is to pursue the standards activities that this suggests. So we're trying to put together a group to come up with a CenterHuff specification for first responders, but also for wherever Internet of Things meets geospatial awareness. So we want to have that as an option for those situations. And the other is this: how do we get stuff into people's hands so they can actually try it? So gonna meet with somebody from the National Fire Protection Agency Association tomorrow, which happens to be in Quincy, of all places, to talk about setting up a survey of their 4,000 firefighter members. And the trick with that is going to be to try to figure out what sort of augmented reality would actually be useful, would actually enhance firefighters' ability by showing them different possibilities. Is text around the margins helpful? Is little flags popping up helpful or unhelpful? How about creating areas of color over the scene that you're looking at? So providing specific examples of enhancing the view of an incident with additional information, and getting a sense of what actually adds to their procedures and what is just playing around. So it's kind of neat, both applying and kind of hiding geospatial science within these practices and seeing where they can go. So thanks. questions or thoughts?
Josh,
Oops.
when do you think this is actually going to be a real thing?
It's happening so fast.
Yeah.
You know. So we heard two things, you know, in this conference. One was the new F-35 strike fighter. Every pilot has to get a helmet made for them. That's this you know, it has connections to all the sensors. Each of those helmets is $500,000.
Gee.
You lose your helmet at a bar, that's another $500,000. But you know, it's connected so that the fighter itself has cameras all along the bottom of the fuselage and the wing. So when you use this helmet, you can actually make the plane disappear. And all you see is the view around the plane when you use it, which is apparently a quantum leap in the ability to maneuver the plane in combat. But on the other hand, these two Swiss guys have come up with, you know, they look like, you know, lightweight bicycling glasses. They're connected to an IR camera, and then they process that with machine learning to decide what are dangerous levels of heat in whatever the firefighter is looking at, and just make, you know, little enhancements to the view that they have. And you know, this is going to be a couple $100 in quantity, and so those will probably be ubiquitous in 2-3 years. So the technology is changing so fast that all we're trying to do is be ready, you know.
I have a suggestion, okay? It is, because you always talk about during this disaster event and some about people and sensors, okay? But I wanted to tell you that based on my experience, okay, also you have to consider also the, you know, how can I say, livestock and cats and, you know, animals in general, because you would be surprised at how people behavior changes dramatically when, you know, they have something, you know, they're responsible also for that.
You're exactly right, and I didn't really mention it, but that's a large motivation for these site sweeps. That's the major reason that people stay in their houses when they shouldn't be, is to look after their animals, or because their cat ran out and they're looking for it to come back. So if you want to help the people, oftentimes you have to help the animals. Yeah.
I have another question. So I noticed this Open Sensor Web was the name.
Open Sensor Hub.
Open something on the URL that seemed to already exist.
Yep.
And is that, my question is, so outside of an emergency situation, right? Maybe there's an event at Harvard, like a big conference or a big concert or something. Could something like that be implemented on a test case with interested parties and have maybe mobile phones or some sensors or some devices, and see, just as an experiment, to see how the catalog works and how the post-mortem works in evaluating an event and how it went?
Yeah, absolutely. So two things. So Mike Botts and Alex Roban have put up this open source software they're continuing to develop, and the drone software is part of that as well. It's a Java software package, and so you can run it on a laptop or a Raspberry Pi, all sorts of things. And CenterHuff, which is Steve Liang's company up in Calgary, is doing a similar thing. Some open source packages that you can run on an Arduino, for example. So with a little hacking, you can put these stuff together. One of the things that really trying to get organized is to be able to put a hub on any phone. So it will run on the Open Sensor Hub will run on a Android tablet, for example, and also on some phones. Running on a Android phone with a FLIR camera edition, for example. I don't have the video here, but it's pretty cool. But it's almost, but not quite, to the point of just downloading an app. And so having a Android and iOS app that sort of throws you and your device sensors into the ecosystem would be a neat step.
Sounds like it'd be very cool to try. Just to see where the technology is and where to go next.
So I'm hoping to play with and maybe show a bit at the drone conference, this modified drone software. So, I'm getting Dave Stroshine excited about it too. So. All right. Well, thanks for coming.
Thank you
Thanks
so
very
much.
much.
Thank you.
Thank you.
Okay.
Just go to that browser, Chrome, and it should say stop.
Oh, this is a new.